This is a quick this is a quick recording to show you how to get the spaces homework assignment done. I'm going to my own website right now to look up the homework assignment. You're not going to see anything on the screen to be recorded because it's not there. I'm using a browser right now. And with the current homework assignment, I recommend that everyone at least give it a try and use a revision control program to do it, because that will help you identify changes that you have made over time, and that can save you time, down the line too. So if you have not used one before, it is a good time to get started with one. Alright, so I got to my homework assignment. I'm going to copy and paste the pseudocode into the assembly program file, and here I create spaces as a folder, and inside I create spaces.s, which is the name of the source code. Paste in the pseudocode, and now it's time to go into spaces.s to actually look at the file. It doesn't look too good right now because the indentation was not copied. We can, in VI, it's pretty easy to do this kind of stuff. Turn on line numbers first, and I can identify which line to indent. In this case, I want to indent from line 3 to line 8, and the indent command is just the greater than symbol, and that got the first part indented. And then we want to get line 5 to line 7 indented. 5, 7, indent, and there's one more line to indent, which is only line 6. And of course, this is all in pseudocode. The assembler will have problems with that, so I'm just going to replace the beginning of each line with pound space, so this way they're all commented out. So now I have a good starting point. The first thing to do is to go to the data section and define count itself. Count is a label. It is defined to be the address of a 32-bit integer. I'll just put a 0 here, but I should initialize it in the code as well. I also need 1 byte for the character as the character buffer, and then I need 4 more bytes, and I'll show you why I need 4 more bytes here for old EAX. Because I want to follow my code exactly in the pseudocode, and this is what I need to do. I'll show you why that is the case. Now I get into the text section of the program, which is the code portion of the program. First of all, I have to export _start so that the linker knows exactly where's the entry point. And here we can get started. Count gets 0 can be done by move L $0 to count. So a single memory operand would do. And then here at the beginning of the loop, I know that I need a label called loop begin or begin loop. Either way it's fine. So I'll just say loop begin here, because as a loop I know that I have to get back to this point at some point. And then here we have to read a character from standard in into ch. To do this, we have to move 3 into EAX, because this is system surface number 3 for reading content from a file. Move 0 into EBX, because 0 represents the standard input file. Then we have to move the address of the buffer into ECX, and in this case the label CH is the address of the single character buffer. I made a mistake here. It should be .field1 to reserve exactly 1 byte, and put it into ECX. And then we have $1 into EDX, because we're trying to read at the most 1 byte. And then we have int $0x80, which is the system call. This is the instruction that asks the operating system to read at 1 byte. When everything is when the code returns from the operating system, the first thing I want to do is to remember the value of EAX. I'm going to store it into old EAX. Over here, I want to say if a character was actually read, then do the following, which basically means if a character was not read, I want to skip around the entire block. To do that, I can be redundant and reload old EAX into, or compare, oh, there we go. We can just go ahead and compare 0 with old EAX. And if it is 0, in fact, then we have to go to the end of this outer if statement. And I will just label, I'll assume that we have a label called outer if exit, and right away I define where the label is supposed to go, which is at the end or after end if for the outer if statement. And we'll just dash it here, call that outer if exit, just like that. And right now the program can actually be tested. So let me go ahead and test the program right now. The reason why I did not finish the program and go ahead and test it now is so that if I introduce any errors, I want to know exactly what kind of error I'm introducing and at what point. So that's why if I test the program more frequently, it's better. GDB spaces. Now the program obviously doesn't do a whole lot at this point, which means I can't really test how many spaces it can count. But what I can test is whether it gets out of the loop correctly or not. Actually, I did not finish the loop here, so because the loop also needs to have some code here. Okay. While a character was actually successfully read, I wanted to go back to the beginning. So at this point, I need to compare old $0 with old EAX, because that's where I store the value of EAX right after the system surface. If it did read something, which means if it is non-zero, I want to go back to the beginning to try to read again. And there we go. And of course I forgot a few things here. I forgot the label check here, and also the proper exit code of the program. Alright, now the program is ready. It should read bytes from the file, from the input file, until it hits end of file. So let's go ahead and recompile and re-debug the program. And we'll just go ahead and run the program using, let's say its own source code, which is spaces.s, and the program exited correctly. That's good. That means I'm not stuck in a loop. The outer loop, the loop itself is done, and I can now focus on the logic inside the loop. Alright, so the only thing I haven't really implemented is if the character read is the space character, I want to increment the count. That means over here we have to compare. Compare long is wrong because I just want to compare a single byte with the ASCII code of a space, and it can use a direct memory operand ch because that's where we store that one single character. If it is not a space character, we branch around the conditional statement, and then we go to inner if exit. And I do it right away here. Inner if exit is defined here. If I did not branch around the conditional statement, that means it's time to increment count, and that can easily be done by add l $1 to count. And I think that should be it. Well, let's go ahead and give it a try. Assemble link. Oops. Inner. Oh, I have a typo. So let's go back and fix the typo on line 24. There we go. And then we debug the program again. This time I'm just going to try it out with the program itself, the source code of the program itself. And of course I don't really know exactly how many space characters are there in that file, but I'll just go ahead and give it a try. Forgot to set a breakpoint first. So let's go ahead and set a breakpoint and rerun the program. And count is 157. I have no idea whether that's really the case or not. Let's go. Well, there are several ways to. Well, maybe not. Yeah, that won't work. Never mind. I was just talking to myself. Let me copy the test files that I used to grade your program, to grade your homework assignment, into here. They're all in the parent folder with the names of spaces, something.in for input files. Okay, let's see, how about that? Oh, to here. There we go. I forgot to specify the destination. Then we can run gdb spaces, and the first program will run. I'll set a breakpoint first. The first test file is spaces1.in, and the counter is 0. That's correct. I'll show you what the file, the test files a little bit later. This is the second test case, and look at the counter. It is also 0. This is the third test case, and the counter is 2, which is correct. And here is the fourth test case, and the counter is 6. I think this may not be one of the test cases when I graded your program, but the answer is 6. And here's the last one. The last one is actually a little bit tricky. I have to explain this one. Well, maybe not, but the result is 1. Alright, so I have ran through all the test cases. It's time to take a closer look at the test cases themselves. One really good useful program to use is called hexdump. Hexdump dash uppercase C will display the hexadecimal representation of characters in a file. In other words, it displays the ASCII code but in hexadecimal, and it turns out to be pretty helpful. We can look at spaces1.in, and there's nothing in the file, and that's why it didn't show anything. It's just an empty file, and as a result it makes sense that the number of spaces in the file is 0. And here's spaces2. Spaces2 has no space, because if we had any space it would have shown up as 20, because that's the ASCII code of space in hexadecimal. And then we have spaces3. Spaces3 has 2 lines. The first line is 1 space, and then the second line is 2 spaces. And here we have the first space right here, the 20, and then here we have the second space, the second 20. Let's take a look at spaces4, which is not one of the test cases that I used for grading a homework assignment. The first line has 3 spaces followed by a line feed. The second line also has 3 spaces followed by a line feed character, and therefore there are 6 space characters altogether. And here we have spaces5. Now spaces5 is interesting because it has just 1 space character with no line feed, no end of line character to terminate the first quote-unquote line. And you can construct a file like that. It should not change the behavior of the program, because we are really just testing the number of spaces, and the line feed character should be tossed away and completely ignored in this case. But it did catch some programs. Some programs did not work in the 5th test case, because some programs rely on a non-space character to always follow a space character to stop the counting. And in those programs, especially when the order of reading the character is, when the checking of the character is done before checking the end of file, then the program will miscount as 2 instead of 1. So apparently this test case broke some programs. Not all, just a minority of programs will not work correctly in this case. And that's it. That's a little quick review of this count spaces program, and I hope you guys watch this and possibly learn something from this particular video. I will do another one after the due date of the current homework assignment.